Hello? Awesome. So, well, thank you very much for choosing my session. I don't see any free spots, so I can't help you with that. The session will be about continuous delivery and antipatterns. It's because, well, as I'm Polish, some people say that Poles like to complain. It's a bit true in my case. My name is Andrzej. I work at eBay. I have a Twitter, I have an email, I have a blog, which is not very active, but it's there. Of course, a disclaimer, whatever I say doesn't represent any of eBay's opinions. And one last thing about me. I'm proud of a few things in life so far. One of them is the Polish Java user group, which I'm one of the leaders. I also run GeekOn, an awesome conference, not as awesome as this, but still, I like it very much, but I'm biased. I run Software Craftsmanship Kraków, and I founded Kraków Hadoop user group. And that's probably enough about me, and on to the talk. Well, one more. If you have questions, well, if those are really generic questions without any details, I tried to, well, work out some answers. However, if they don't really work, just raise your hand, try to shout. If I hear you, I'll try to repeat the question. Well, if I don't hear you or don't notice you, well, sorry, try to catch me later or tweet or have a conversation at the beer. And, well, you know that, keep on tweeting. Tweeting, feedback is really very important because otherwise I don't know what I do wrong and whether you like what I do, or should I maybe stop. So, if you're a bit sleepy or had one too many at the Java Posse already, then, well, too long didn't read version for the talk is just release more often. If somebody doesn't, well, somebody says that it's not possible, don't trust them, it is possible. To me, software is a people's problem. Unfortunately, it's not that often that we have to deal with really interesting algorithmic, technical difficulties. Mostly it's about procedures, it's about who does what, it's about sorting out, well, people-created, people-oriented mess. Same goes with delivery, since more people are involved, and since delivery actually touches the business people are involved, so it gets tricky. So, well, let's imagine. In the beginning, well, we can start with something that you probably all recognize. Do you know where this quote comes from? I've heard Agile Manifesto, whoever said that, you're right. I have no idea where you're seated and I have no prizes, unfortunately. But yes, that's Agile Manifesto. They mentioned continuous delivery in 2001. Continuous delivery of valuable software. So it's there, it's not a new thing, it's not a, well, 2010 thing. Yes, the book was written in around 2010, but the idea was out there. One thing that's, well, very important that I've learned so far is that delivery is really very organization specific. If you are an organization that is doing software as a service model, your delivery problems and solutions will be completely different for example, Oracle, who has to ship a JDK and then maintain it, and then it's out there for, well, forever. So if you're a games developer and you have to deliver for a very specific date because there is a gaming console being released very soon and you're one of the launch titles, of course your delivery cycle will be much, much different than, well, let's say Salesforce. So, change scenario means that how do you ship out changes? Can you ship out changes really differs. You have to look at whatever I say through the lens of your organization, of your business reality, because business reality kicks back, and sometimes it just kicks back hard. What you have to do when you have problems with delivery that you'd like to solve is, well, first create a list, prioritize them, then you do pick the first one. And after you fix the first one, you don't go after the second one. You have to, well, repeat making the list, because when you fix actually the biggest issue that you have, it might just so happen, and it happens very frequently, that the list gets, well, reshuffled, or you get a completely different list, because when you killed, for example, long delivery cycles, you actually had to improve, well, how QA worked in order to be able to fix that. So whatever your issues are they will, well, things will change and things will change. So Let's go with a story. Imagine a situation in a hypothetical place a long time ago in a galaxy far, far away. There is a system. Well, system like many of them working, in the internet. There are developers. They work everywhere. Some of them are in-house, some of them are outsourced, some of them are offshore, some of them are nearshore. You know the situation. What developers do, of course, they code. Oh, a cat picture. A friend told me that, well, a presentation without a cat picture is a waste of the internet. So, well, since I'm intending to put that into the internet, of course, there had to be a cat picture. But coming back to developers. Developers develop. They push their code, and as it happens, something breaks. Let's think about an e-commerce site. Well, the site breaks, and it breaks for 2 days, so it means revenue lost, transactions not happening, customers getting, irritated, to say the least. And now imagine it happens during the hot season, whatever that is for your business. If that's a console launch, if something doesn't work, you know how it hurts. If you're caring about the Black Monday, you know what failure during that time means. If you care about, it's really a very business-specific question. You have to ask your business what the hot season is, but you don't want to fail at the time. The first thing that you do when things are starting to fail, the decision is all roll back. And what you have to do after is, you have to decide to where. And, where are we exactly? That's the first problem that is unfortunately quite frequent. Nobody knows what's deployed. Nobody knows where is it deployed. We just have a bunch of machines, and they create a system. How can we fix the problem that we have just found? Well, we can just push something somewhere, because we have no idea. So what can we do? Well, we can do versions. Because, versions are human-readable. Versions are, for me at least, much better to remember than hashes, much more understandable. There is an awesome thing that's called semantic versioning. It's very well described on the site that's linked there, so I'm not going to talk about it. The thing is that your applications should tell what versions they are in. So if you look at an instance of your application, there should be probably a switch, a flag, a URL that can tell what has been built, when has it been built. You've seen it on at least a few places already. It should be consistent with what the app reports, and you should be able to access it quickly. So when something fails, you know where to start. You also have to know, what is where, which means just have a dashboard. It can be on paper, it can be a database, it can be anything. I've committed a few Grails-based dashboards that solve that issue exactly so far. Usually it starts as a very simple thing, and then it grows to a very business-specific thing. It's awesome when a business person can actually read it and understand it. But if you don't want to reinvent the wheel, or if you're not into shaving yaks that have already been shaved, there is a thing that I personally like. It's called Glue. It's open source, it's on GitHub. From my experience, it mostly works, so, just give it a try. I'm not going to promise that it will fit your organization for sure, but for my needs, it worked really well. So, let's go to another problem, because, as I said, we have developers. We have many teams. They push to different repositories, perhaps because our organization's security policies are, let's say, very complex. Some people don't have access to the main repo, so they send in their patches through email, or they upload it somewhere, and then it gets integrated somewhere. If you're wondering, yes, it still happens. I stumble upon such things quite frequently. What you can do if there are multiple repositories in which developers develop, it's actually okay. It's not it is a bit of a problem, but there is a solution. You can have another repository that you actually build from. That will be the one repo that is sacred, that, developers cannot break. They can break, but it should have more resiliency built in, probably by some automated testing. And also, when you do releases, you do them from there. So if developers delete a branch by mistake, especially if those developers are, sometimes never been formally trained in computer science or programming, then that's a solution that works. It adds a bit of overhead, but, well, it's always up to you. If that's something needed, it might help. It helped me at least a few times when working with a country a few time zones away, both to the left and both to the right. So it's a good one. Another thing is, if you're on Git, you could use Git flow, because why would you reinvent the wheel? Some of the wheels have been already invented. Link is there. Again, I'm not going to go through that. My personal favorite, though, is something that's called the stable master. So develop on one branch, don't do feature branches, don't do other branches. Keep the trunk, keep the master stable. Of course, if you can, because if you're really, if you have to support a number of customers with different code bases, then it might get tricky. It's a very business-specific decision, but if you can, that's my personal favorite, and I wholeheartedly recommend it. But coming back to our situation, the site broke, and business starts to think, well, what happened? What should we do? Of course, business gets angry. That's first. Then they start asking questions. They think about the dollars that are just slipping through their fingers or clothing. And that's the conclusion that they get. Releases, risk. They start with the same letter. It's not without a reason, for sure. So that's risk. So what can we do with risk? Of course, we can avoid it. So what do you get when you want to avoid risk, which is called releases? Well, you get something that I call fear of releasing. You can call it stagnation. The symptoms you know probably only too well. Those are quiet periods. Those are, release trains. Sometimes those are called RC. Those are called beta versions. Those are called gold versions. Code freezes, user acceptance testing, binaries that get sent to customers, and they wait. And as we all know, software is just like wine, so if we get a UAT version, zip it, send it to a customer, it waits for a year, then when you launch it, it will work much better. Well, I thought so, or not really. One of the customers I worked with thought so. They actually did that. They had a UAT version waiting somewhere for a year, and surprised when they tried to launch it, it didn't work. So, what's the solution? Well, you can do, as they call in the business lingo department, you can manage your stakeholders. You can just talk to your business people. Yes, I am a software developer. I like my cave. I have my desk in the furthest corner in the office, just next to the window, so I can jump in emergencies. But if you talk to the business, if you actually tell them that, you see, this tiny little feature, it's only 2 lines, how long do you think it should go out? It passes all the tests. Our build takes only, let's say, a day. With all the builds, all the seleniums, all the things. And why do I have to wait half a year to release that? And usually you'll get a business person that, small code change, it should be, pretty much deployable quickly. So when you talk about, that's the approach that I frequently use, and it works, which is, for my reality, quite awesome. What you have to do is you have to reestablish trust. When you work with your business, and that involves listening to them and trying to speak to them using their language. When you can rebuild this trust, you can actually, rebuild trust into releases, because that's effectively results of your work. Selling point, again, small changes should happen quickly. That's just natural. That's built in right in here. That worked quite a few times already for me. There has only been one situation in which people were really afraid. And then what we did to the business, we started shipping our JUnit tests to the customer. We have exposed a JUnit runner. It was around version 3, I think 8. So the customer would actually click on the tests. They would run the tests, see everything green, and then a magical thing happened. They started deploying onto production. From whatever we shipped, if the tests passed, they deployed to production. And that was actually an airline. So it was, a big savings point for them. They saved quite a lot of millions just by showing them that, yes, trust us. We show you how we test our software, but don't trust us when we say, it worked on our side. Run it on your side. If it works there, make the decision. So let's go forward to, build ends. You probably have a pipeline in your Jenkins or TeamCity or something else. The problems with pipelines usually is that they are slow. Solution? Well, linear process, well, parallelize. That's what you do. The question becomes, well, which part? In the ideal world, where memes speak the truth, you can parallelize everything. In reality, parallelizing absolutely everything is hardly ever possible because it's a lot of work. It's a difficult thing, separating your tests from, well, test dependencies, making your integration tests be runnable in parallel. Sometimes it's just not doable, sometimes it is. You have to make the decision. As I said in the beginning, pick the biggest pain in your pipeline, pick the longest process, try to split it, maybe run it in parallel. Whatever hurts you the most, you can start from there, and then it will get better. What you will get for free, if you can parallelize your build pipeline, you will probably get a decoupled design. I'm saying probably because, well, there is the ideal world, and then there is the software reality that we have to live in. But usually it's a win. If you can get your tests, script your database builds, automate integration tests, it's usually an awesome thing. And let's go to another problem, because with pipelines, we sometimes get a problem that's called, well, just recompiling. So you get a pipeline, and if you're using Maven, starting with Maven clean something, at each of the stages, you recompile it probably, well, in that many of them. And now it depends. If recompiling is what you actually enjoy at work, for example, for those reasons, then that's of course okay. But I don't really feel okay when I have to wait for the computer. It has to be fast, yes, because I feel always almost a physical pain when I can't do what I want. Because those thoughts, how to do awesome thing, how to make my software really awesome so quickly, are just so close, and I wait. I see Maven running, I see SBT compiling. It takes time. So what can you do? Well, you can just collect the binaries and use them in all the stages. They should be the same binaries. Why? Well, because if you're doing different binaries for production, then the question becomes, how do you replicate production? Because if those are not the same binaries, then, well, what is exactly running in production? Do I have some magic flags? If you have been lucky enough to work with, well, C, C++, things that, well, places where you have to actually treasure your sets of compiler flags, you know why. You know the pains already. You have to be able to replicate your environments to be able to debug things. The solution is, well, quite easy. Use a binary repository. In the Java world, there are a few products that work really well. Who uses a binary repository? If you can just raise your hands. Yeah, and that's, from what I see in here, half of the people. I don't know why it's not everybody. That's what my gut feeling tells me, but maybe you don't know, maybe you're already a bit sleepy, or maybe the hand is just too heavy. Anyway, binary repositories, Nexus, Artifactory, some other things out there, they are quite awesome. The thing is, just save your time, use the same binaries. Also, if you can execute tests against the same binary instead of just running it from the code, you'll know your tools better and your code will become better. Let's move on. Another problem, well, my favorite one, is called separate teams. Imagine a situation in which you have a release team dealing with danger. So the release team, they do those dangerous things. They are sometimes referred to as, well, the sacred people. You cannot interrupt them because they are releasing. If they don't release, things go bad, business is unhappy. You know what happens. Unfortunately, well, if they deal with danger, they are smart people. I would assume that. So job security, if they care about it, some parts of the process will actually be manual, because why should they be not? Because if they make themselves redundant, that's not really smart. If they enjoy the job, why would they? So it creates an unfair situation. They can slack, they can leave, they can, well, not come to work, or they can say, well, I won't help you today because I'm releasing. It creates bad atmosphere in the office. It creates a situation in which it's us, the developers, us, well, let's say the ops team, versus them, well, the release people. Or sometimes it's dev versus ops. You probably have a very good gut feeling of what happens. there was a company I worked for. We started a new office in Krakow, and a funny situation we have observed. There was an ops team sitting here, and there was the development team sitting here. And when you actually looked on a rainy day at the food trucks, people worked directly to their development desks, people walked directly to their admin desks, nobody crossed the line between those desks. The teams were not communicating. That was happening so far as they were not even trying to avoid each other actively in the kitchen. Is there somebody that I cannot talk to? Well, I'll wait with my breakfast. That's not fun. You probably know it very well. If you don't want to talk to people and that's half of the office, that's really not fun. Solution will come later. Also, what you get when the teams don't talk to each other, well, the processes that you have to use to release software become really curious. Really, really curious. You have to make 3 turns, well, to the right, then you have to use a pinch of salt, then, I don't know, play a game of Minesweeper, and then only you can use a special version of WinSCP, for example, to deploy the software. Nobody really understands why, but this is how we do it, and, well, how dare you tell me that I don't know, I'm releasing. So when you allow those processes to creep in, then something that's called the Parkinson's law creeps in as well. Bye-bye efficiency. Of course, developers are not stupid. So when the processes become too curious, and also business people that you work for probably are not stupid as well, you get unofficial releases. So yes, technically we release once every half a year, but then a big telecom company had actual Java code stored in their Oracle. And what the software would do, it would just get the latest version of the code, compile it, and run it. So what would happen? Yes, the solution provider was allowed to have access to that database. Yes. Unofficial releases, well, they are not awesome. They are bad. Don't do them. Why? Because you don't know what is where. You don't know who did what. No auditability, no trackability. If you'd like to fix a bug in an unofficially released software, well, good luck. That's just impossible. Also, you just might break things because if you don't know something about, well, what the release process involves, because it's really curious and only described in a wiki that you don't have access to, well, tough luck. So, curious releases processes, dev versus ops, or release team doing, well, sitting in their bunkers. Well, it might not look like that, but that situation in the office when one team would sit here, one team would sit here, and nobody would cross in between actually happened. So, well, the solution? Well, I can use a buzzword, say encourage interactions. Yes, of course, we'll go do paintball once. Of course, it will not help. What you have to do is you have to somehow break the barriers and integrate the people. What helped in that very situation is we started playing a game. Every day, because it was a new office, we started playing a computer game. It was part of the work time. We were playing Enemy Territory Wolfenstein. You might be surprised, but the reason is very simple. It is a shooter, but apart from it being a shooter, you can actually have team goals. So if you get 2 awesome shooters in one team, but the other team, comprised of, well, a mix of people, actually starts to work together, they will win. When people in the office realized that, they started playing together. They started acting as a team. And then magical thing happened. A developer shouted at an admin, or the other way around, doesn't matter really. So they started to talk. Of course they were shocked, because, well, they were not supposed to do that, but it already started. The bridge was crossed. So we were doing that continuously for a few months to make sure, well, that people actually talk together, integrate. Well, a side effect that we got is that our manager, who at first tried to lead one of the teams, it turned out that he's not the best at computer games. He's okay, but not really the best at this very game in particular. So teams started to self-organize, only inside the game. But, well, that was the start. That was the important thing that we wanted to see. And then, magical thing happened. On a rainy day, you would see foot marks everywhere. Of course, the cleaning lady was not so happy, but... Games are awesome. Repeat the events. One event of paintball, one event of go-karting, Luna Park won't do it, unfortunately. As much as I would love to, but, well, you have to repeat it. Those interactions have to be encouraged. They have to happen. It has to be sometimes forced. Look at your own office. You'll probably find a way. Another good thing is those guys are geeks. You are most probably geeks. You can find a geeky subject, or if you're not geeks, some of them have kids, some of you have kids, you can really find a subject that works, that you can talk over lunch, you can talk over coffee, you can just, well, moan on a rainy day that, yeah, the weather sucks. Yes, it sucks really well. By the way, what are you doing? Well, I'm deploying. Well, can I sit with you? Well, sure, I'm bored anyway. That works. Comic books, movies, you have to find the thing in your own space, but for sure you'll be able to. So, we're talking about those, about admins, ops. What they deal with is infrastructure. There is a very bad thing that's called manual infrastructure, or when you actually massage all of your machines by hand. Why? Because people scale really well. If you want another me, I don't, but well, if you need to, well, the solution is very simple. You need a male and a female. You need to wait some time, probably make sure that the offspring becomes a geek, teach them the right skills, hope that they actually want to stick with computers, hope that it's not really sick, and then in 25 years you get another developer or another admin. Yeah, perfect scaling. Let's start. Actually, well, you know how hard it is to hire the right people. So when infrastructure is taken care of in a manual way, if you want to add a machine, it requires a lot of work. If you want to remove a machine, change a machine, it's all manual. So you might lose things, because when I'm doing things which are not scripted, I sometimes forget to run something, or I change the order, or again, let's say I play in a round of Minesweeper, and then of course I start, and then I say, yeah, probably why it worked, it was because I played with Minesweeper. So manual infrastructure is a problem. So what can you do to help with manual infrastructure? You can treat infrastructure as code. If you heard of Chef, if you've heard of Puppet, if you've heard of CF Engine, that's how you do it. There are, of course, other tools like that. But then there is a trick. Because, yes, you can use Chef, you can do something like that. By the way, DevOps Borat, highly recommended. If you're into sarcasm, the guy is awesome. So the solution is quite easy. Whatever you do, you have to test. How do you test infrastructure? Can you actually do unit testing? Because that's what we developers do. Actually, yes. You can do TDD or TDD-like activities with chefs. The reality is that developers, in terms of testing, are light years ahead of some of the admins. So if they struggle with writing tests, with writing actually useful tests, you can work together. You can sit side by side, try to do TDD. Sometimes it will go hard because testing in Chef is good, but it's not perfect, and it depends on the cookbooks that you use. It's a great way to work together, to learn, and I highly recommend that. If you don't know how to start, this book is one of the possible starters. Another is, of course, GitHub with the proper Chef testing framework repo. There is also a tool called Food Critic, which is basically a lint or a static analysis for Chef. Again, we know that from our own lanyard very well. There is also something that's called Vagrant. Who knows Vagrant? Yeah, so, well, I don't have to explain that to most of you. It's a, well, very nice command line driven tool to manage your VirtualBox and not only VirtualBox machines. And it's really awesome. If you have no idea what to try after I speak to you, try Vagrant, try Chef. It's an awesome start. It's also quite, well, for me it's fun. The question sometimes that you might have in your company, should I use Chef, should I use Puppet? Talk to your admins, try to use the same. Why? Because they will be able to help you. And you also probably have a repository of things that actually work. So you get something that, well, works, something that you can talk about, and you get the experts for free. You need to ask questions. You can go to Stack Overflow, or you can just ask guy 2 desks away. If you don't have a tool like that, well, it doesn't really matter which one you choose. Pick the one that looks better. Pick the one that's, well, play with one, see if you like it. Just roll with it. So let's move on. Because infrastructure and infrastructure as code means that you have to build your environments from code. So you get builds. Builds, pipelines. What happens? Well, they are slow. You know the solution already. Again, how hard is it to parallelize, the infrastructure builds? Not that hard, but it requires some skills, because then you probably have a Debian package repo. You probably have a system repo that you need to integrate with. You probably have a VMware or an OpenStack or something else. Or if you're on a PaaS, well, that's much easier. But some work together might get things done really quickly. Which brings us to another problem, which is called the internet. And there will be a quiz with, again, no prizes. Do you know what these machines like the most? What's their favorite treat? Any ideas? Yeah. They love your internet. They love your fiber. They love your gigabit connections, 10 gig connections. Whatever your office has, this is the thing that will, of course, want to eat it. And no, those things shouldn't happen because, well, the lines are, of course, in plans. Yes, the plans say it's on the left side of the street, and then construction happens on the right side, and you know what happens, the whole quadrant or block or whatever is it in your place doesn't have power, doesn't have internet, and because it's fiber, you have to do it properly, so it takes a lot of time. These things happen. I was in Zurich earlier this year, and an unthinkable thing happened. There was a power outage. If you can imagine the shock of Zurich people that actually, well, we're in Zurich. It's not supposed to happen. That's exactly what happened. But yes, still, there was no power. So we had to walk down the stairs with, well, using our mobiles as flashlights because there was, well, nothing for the emergency. Not my kind of fun, but of course, internet wasn't working. Also, if you get to travel a bit, or if you have to, security zones, well, airports, internet sometimes is paid for, sometimes they block ports. It's really hard to do sometimes to get things done without the internet. So the question is, do you need it to build your software? And the answer is, of course. Why would I not? But really? You might have experienced one of those sites going down. Ruby gems, well, they went down after a few serious flaws a few times earlier this year. CPAN, yes, if your network provider breaks their configurations, that will disappear from the part of the internet you're in. Maven.org, yes, it's usually out there, but it doesn't mean that you can reach it from your office. So, well, you can try making your build run without the internet. Or, well, if you can't really succeed, sometimes it's okay, but you'll learn a lot of interesting things. Actually, where your dependencies come from, you can actually discover that some frameworks pull a single commit GitHub repositories into them when they build, which is probably not what you expect, but yes, that's the real world. That's sometimes what happens, because GitHub is really awesome, but everybody can push to GitHub, and everybody pushes to GitHub, and you get everybody's code. I think that it's generally a good thing to know what's running and how your system is built. And then you can, of course, optimize some things. If there is something that gets fetched from a server in Canada and you're in Europe, if you can make a proxy or if you can put things in your corporate Nexus, corporate Artifactory, put it, well, closer in your network, or maybe just have a cache. That will speed up your builds. Everybody will be happier. Another thing is, unfortunately, well, those sites are in the internet. You don't own them. They might get hacked. So that means that there is some probability that somebody might change things that actually you get in there. And then, suddenly, your software will start working differently. Maybe there is, well, this famous social network that everybody's supposed to be on, even if they didn't subscribe. Maybe you've got a module that actually sends data to there. I don't know how it works, so maybe. You never know. So make your build run without the internet. Well, application, and environment. Because packages, if you use system packages, they usually come from somewhere and then those mirrors disappear. And especially if you're paying for your bandwidth and you're having a fleet of a few hundred VMs and you would like to fetch all the packages for all of the VMs separately, that doesn't really make sense. It will just take a lot of time. And it will make your life quality much, much better and everybody more sane if you can just save time, save nerves, and, well, have binary repositories, proxies, what have you. OK, let's move on. Runtime upgrades. If you've done any Ruby, you might have encountered a series of security problems that Ruby guys have. A friend of mine actually did a website. As you can probably guess, this text is static, except for that, well, the guy was kind enough to update the dates. The screenshot is kind of dated, but doesn't really matter. The thing is, well, framework that people were using, Ruby on Rails, had problems. So in order to get rid of those problems, you had to update your framework. And now you can get automated tools that will just crawl the internet and look for Rails in unsecure versions and automatically exploit them. And it's happening. It's happening to so many sites. And, well, but we're on Java. Java is better. Well, you probably, those marked in red are the updates that included word security update in them. I don't know if that's really security. I just went through the list of Wikipedia and read the change notes. It's a bit red, a bit too red. So you have to keep updating. I've heard a guy this year, this October, who said that their company just upgraded to Java 1.4. That still happens. Desktops, upgrades. Firefox used to be my favorite case. It's not anymore because Firefox upgrades are not as bad as they used to be. You might remember when you tried to launch Firefox, Firefox is actually upgrading, and then you have to wait for 2 reboots. And if you had a bit of plugins or extensions, it took a lot of time. That made me switch to Chrome, which does it really awesome. But Firefox is updating, and I can't use it. I'm a user. I want to use my software. If the software is doing something else, can it do that in the background? So, well, luckily, they realized, they fixed it. But you know the pain. If you're doing a desktop application, that's a bad thing, because people will try to, well, find a replacement if they are really irritated. Mobile applications, well, if you have a web view, it's awesome. What I noticed with an application I was involved in is that frequent releases make your users curious. What happened? We were releasing, well, daily for a bit into the Play market, and we noticed that actually people started leaving our application. We were really confused because, well, bugs, no, well, the exceptions, well, nothing, but somebody sent an email, guys, you probably have no idea how to do software because you can't release a proper version and you're eating up all my bandwidth. Bye. And on the mobile market, there is so many alternatives for so many apps. If you have to fight for your users, well, you don't want to make them angry. The good thing is that you can change backends. The bad thing is that you have to maintain backends so that if somebody sits on an older version, can still use it. So you have to make an auto-update mechanism that will somehow ask the user to change the versions. I'm saying ask because forcing doesn't really work because, well, at least I do it like that. That's my computer. I know what I want to do. Your application should just shut up and let me do my work. So there is a mind trick you can use. You can ask, would you like to have some new features? And, well, who won't say yes to that? Everybody wants new features, especially if you promise performance improvements. You don't have to build in thread sleeps or, well, whatever it is. Just promise them. Promise them, that will do the job. So many people, it's a placebo, but it works. So, moving on. With deployments, you get failures, of course. If you get them too many, people stop to care. If people stop to care, deployments start to happen even more often, and then, well, you know the situation. Well, build is great, nobody cares. What you can do is just have a counter. We've had so many days since the last failure. Does it work? Yes, especially if you say who did the failure. You can have it, well, some form of information radiation. Tell who failed it, promise to remove the name after the failure has been fixed, or after a day of success or a week. Have it in a prominent place in the office, and things magically should start working. Of course, if you have remote offices, situation gets trickier because you have to actually ship TVs over, set them up, and everything. But just such a simple thing changes a lot. You know this situation very well from your build monitors. Who has a build monitor in their office? Yay! More people than binary repositories. So yeah, that's probably awesome. Deployments. When you deploy, you have to track it. You have to know when you deployed to where, in which version. And because sometimes things will fail, well, you have to track you have to be able to react to a failure. Rollback. Should I do downtime? Should I don't know, call the guy that usually sits there, but now is in vacation on Hawaii or something? Should we do an inverse migration of the database? Well, you have to know what to do. You have to test your rollback, and you have to test your backups. There was an organization that had MySQL installation, and they were doing backups, and all the backups were surprisingly small. There were not 0 bytes because that was a compressed file which included some metadata about times and who specified that and why. But as you guess, database data, no, it wasn't there. Because why would it? Because nobody has ever tested the rollback procedure. Nobody tried to use this backup to actually restore things. So if something would go wrong, they wouldn't know. And then, of course, as Murphy works, surprisingly consistent, the bad thing happened. So their MySQL cluster went down. Oh, we have backups, we are safe. Oh no, it's empty. They got a sizable bill from one of the disk recovery companies. In the end, they all stir up, but well, the problem is there. They test their backups right now. They actually, after they take each one, they try to restore it to a cluster. That's a good way. It's automated, so they don't have to worry. They actually have a dashboard right now. But databases usually contain a problem that is called state. State as in long-running processes. So you have some state in the database, and then things goes down, and then you have a cluster of machines, so you deploy new version for, one machine by machine, and then, how do I approach that? Actually, this topic is big enough that I'm not going to cover it here. There is a paper called Sagas, which is quite old, but still it's a very good read. I highly recommend that. There is a good book about refactoring databases and living with database changes. And, if you like to talk about other things you can do, that's probably a material for quite a few talks, so nothing more there. But environments. Environments, I mentioned we have many machines, so what happens with, some of them fail? You should be able to work. So, love partial failures. There is a good, very good test that you can have if you have multi-component application. Launch both processes somewhere that you have, keyboard access to, and just do Control-Z on one, and see if the other one works. It's surprising to see, how many things actually break by a single Control-Z, or just nicing the process so that it stops responding. So if you can still be alive when, for example, a payment provider goes down, it's awesome. If you can build in switches that actually disable parts of your system when something is, not happening really well in the internet or in the world, that's even more awesome. Make your applications aware. Build in auto-discovery, be able to react to which environment the application runs in. It's probably okay, it's part of your business anyway, so that's like your domain logic. Yes, it's configuration data, but if you do it, you can start and see what works the best in your particular case. But environments, production, what about dev environments? How long does it take a new developer in your organization to start? How many till the code that he writes or she writes gets deployed? Is it a month? Is it more? Is it long? Is it on the first day? A week? A month? Well, it depends on your business, because if you're working with a very formalized environment, it will probably take a bit to set up all the accounts. But ideally, somebody should just be able to fetch code from GitHub or whatever version control you have, run the builds, and, well, be able to work. So how do you set up your machines? Of course, you have those special property files that you have to put in places, and then you, well, run it using special set of scripts. In one of the places I worked, the whole procedure, well, it was considered normal that if somebody manages to get the code compiling faster than in 2 weeks, the guy is probably just too awesome and he'll quit instantly. And what we did, we started changing the setup procedure. We started having a setup procedure because that was a big legacy system which involved make files for Java, because why not? How do you approach such a problem? Well, you automate. With what? Well, Chef, Puppet, you know them. There is a new thing called Ansible or something like that. There is probably a typo. There is Docker, there is Vagrant. Try the name that you like the most, see how you can use it. If you can actually make developers have the dev environment work, in a few minutes or in a few hours after they join, that's actually really, really awesome. It's an awesome thing. The companies boast that their developers commit and push to production on their very first day. And sometimes it's not really that hard. It's quite possible. If you can do it in the first week still, I believe so many people will be amazed that it's done. But I'm speaking of this Chef. What does a Chef look like? Well, Chef is quite simple. It's a Ruby DSL for expressing system packages, system configuration. So you can see package with an action, and you probably know what it does. You see a template with a source, with an owner, with a mode that notifies a service. I find it really readable. And the good thing is that there is a lot of those cookbooks out there in the internet. The bad thing is that there is a lot of cookbooks out there in the internet. How do you know which ones are good, which ones are not good? Well, you have to, unfortunately, read them. It's a DSL, so it's usually quite easy. You can talk to your admins. They might have their own repo or favorite selection of packages, and you have to test. That's the only way, because there is a lot of them on GitHub. Some of them are like those single commit frameworks. Some of them are really awesome, really well done, really well tested, work on many operating systems. Sometimes they are probably they may be just for a particular version of, let's say, Ubuntu, or maybe a particular release of CentOS. That happens with everything that's in the internet. So try to put that code into your own GitHub. Don't use submodules. That's just an experience trick, because I have never seen submodules work really well. And really well as in so that nobody would never have problems. Sometimes it always happens. And the bottom line is that you should always be able to build up your production machines without using the internet, because somebody might, well, for example, delete their GitHub repo. Or GitHub might just go down or be displaying unicorns. It happens, well, in all the ways. And so if you do all those things, you can, well, release until, well, you release a beast called the Kraken, if you remember the movie. And that would be all. If you have any questions, I'll be happy to be shouted at, or we can do that after, well, later with a beer at hand. Please tweet. Please use the feedback machines. I would love your feedback. Any questions? Probably no. So.